So this is the upstreaming BoF. I have no slides, so hopefully it's much easier. Basically, the last time we had the slides was just bullet points that nobody looked at anyway. So basically, this is to see if we have anybody wants to talk about anything going on with Qualcomm chips in the upstream kernel. Also discussing the open issues you have or trying to resolve things. So lots of familiar faces right here. I can go through bullet points if you want, or people can just raise their hands or be excited and grab the microphone and talk about something. Anybody have any interest in talking about any topic? Otherwise, I'll just go through my bullet point list from last time, and we'll just go that way. Okay. Complete silence is good.
I think we do have some RMS and then new topics. I said I think we do have some RMS and then new topics, but maybe not the right people here.
So there's some problem with SMU that you want to talk about, but not everybody's here? Is that what you're saying?
I don't think there's anyone.
I'm here.
Oh, okay.
Orange is here.
But I
know nothing about this problem.
We can come back to that. I mean, that's probably after some of the more base enablement stuff.
Okay, we can come back to it if you don't want to talk about it. I don't care. Okay.
We'll walk around in a room later.
Probably beer.
So from my list, I just start with what we call base core inside the company. And from the previous time, it looks like we're looking at sock info, which is still not done, from what I recall. And the person who was working on that in the company is now gone. So basically it's orphaned code at the moment. And that one's just kind of hanging out. I don't know if what's going to happen to that patch set.
Who's working on that?
Yeah.
Okay, yeah.
He's gone, right?
Well, then you should yell at me for that.
Okay. We'll just yell at Brian to do sock info.
I can help get that reassigned, so
Okay.
let me know.
Well, last time Rob was blocking the sock info stuff because it's some DT binding thing, so.
No.
Right, or it was a sysadmin thing, actually.
Yeah.
So the problem is that the sock info, the one driver, allows or has the sysfs interface for checking the version of all the different firmwares of all the different pieces. And Rob quite clearly wanted that in the individual drivers. So the ADSP driver should have the ADSP version, the RPM driver should have the RPM version, and the TC driver should have the TC version. And that makes a lot of sense unless you actually look at the practical side of things, that there is no real RPM driver and there is no real TC driver, or there isn't one TC driver at least. And for most of these things, there isn't a good place for them. And we actually need this driver, we need this interface, because every now and then we get the question, which bootloader do you actually run when you report this bug? And there is no other way to figure that out than reading this information. So it's something we want, but
for that use case, I think we can just put in debugfs, merge the code, and we can think about this sysfs ABI 2 years from now, whenever we actually need it. I don't know. I work inside the company. I don't even know who uses the ABI. So if we can find out who's using the ABI, that would also be useful.
I'm pretty sure that there's some code looking at some of the properties, but definitely not the version strings. So,
not upstream code.
the code that will never see upstream, but will run on an upstream kernel.
Right. The socket has two interfaces. It has the user interface in sysfs, and it has a kernel internal interface, and those are used differently. So you can access the same information, but obviously something not having any internal users doesn't mean that nobody's using it.
Okay. So we'll just restart this task, and once Brian figures out what to do. Just let someone do it inside if it's really an issue. I don't know. After this, I have a peripheral image loader. I don't know what the status is going. You want to talk about that?
The status is good.
Great. How about SSR?
I found lots of bugs in the image loader.
Okay.
I would hope for a little more testing before merging it. Just general comment. Just a little more build testing.
Yeah, except that comment.
Everything else is good. How about subsystem restart? Is that still going on?
Yeah, there's still a few more pieces to land.
And we'll heavily test it for around.
The saddest part is that in every cycle there is some stupid kconfig thing that ARM finds. So I'm not sure if that's the specific thing that you're looking at. And I wish I didn't give you the opportunity in every kernel release.
It's not always you. It's most of the time it's other people.
Yeah, but I'm responsible for giving you the opportunity.
Okay. Next is memory management and SMU, which is basically your topic. That's what happens. But before that, we can talk about. I don't know what this is. From last time, we talked about CMA, and let me be clear, but I don't think any of that was important.
Well, I'm not sure if did we fix the bug in the GPU driver, whether like we had the same bug in the video for Linux driver and the FreeGNO for like the way that the firmware got loaded through CMA.
Terrific.
Yeah.
Solved.
I think the patch that that was suggested was merged.
And both. I did the
Yeah,
same
both.
place twice.
Yeah, and then I talked to Steven because we have more or less exactly the same setup in the pill drivers, and there is a huge problem in the fact that after you have jumped into trust zone, you're not allowed to touch that memory. I'm not sure if that's the same for the video or for the GPU, but if you speculatively read that memory, you will see an instant reboot. So downstream, that's solved by having a DMA allocation where you can specify that it's strong in order. So it's an extra DMA attribute flag, and upstream we don't have that, and yeah.
Yep.
So the problem apparently is that the specification for the firmware interface just says, well, you put the address of the buffer here, but it doesn't say whether that's a virtual address or a physical address or an address as seen by a device that you would need to specify. Like it's just not well defined what the interface actually is supposed to be.
Is this about the pill memory interface? Because that's all physical addresses to trust zone.
And then it doesn't state anywhere that it's a physical address that after making that call you're not allowed to touch it. But the API actually, or interface states that it's a physical address.
Because the bug in the drivers was that they used the DMA address rather.
The drivers use the DMA address rather than the physical address, which happened to be the same by chance, because it wasn't using an IO immediate.
Okay, I don't remember this bug at all.
Okay.
Well, I'll look at it. If I,
No, it's gone.
it's fine, right?
It's
It's always on.
Should be fixed, but it might come back if someone else copied the same code and merged
Okay.
another driver.
Okay. I think, okay, so now should we move on to the SMU discussion, or? What I have on here is says clock and power management and fault handler stuff, basically. Well, those are still going on.
Yeah. Yeah, so I haven't been following it super close, but there has been some iterations on different RFCs for how to handle the power management. So the power management is only one of a bunch of things, but mainly we don't want to have to PM runtime get the GPU in order to unmap a buffer, for example. So there was a proposal about invalidating the TLD before the IOMU powers off, so that we don't have to do it on unmap. I don't know. Have you been following it that too closely? I don't know. I've been mostly letting what's his name? Yeah, I've been mostly letting him and the ARM guys discuss that particular topic and see where that goes. I mean, I think there's two different kind of use cases the ARM guys have in mind for ARM SMU. One is like a network driver where you're always going to have the device on when you're unmapping things, and you want to be able to unmap things from potentially an atomic space, so you don't have to do a PM runtime get in the IOMU driver. The other case is like a GPU driver where unmaps might potentially be under control of user space and happen long after the GPU is already shut off. And it'll never be called in an atomic context, but we don't want to have to boot up the whole GPU just to unmap the buffer. I think the issue there, I think that particular issue is understood and will get sorted out somehow.
When you say unmapping with the PM wrap, would the unmapping always be done synchronously on this driver, or could we also do a lazy unmap like we do on other IMUs? Because that would change the whole question, right?
So, I mean, I would actually like, I mean, I am kind of a fan of the asynchronous stuff being added at the ILMP level, because it would take some more work in the GPU driver. I need to keep the pages backing the buffer around after I unmap.
You don't need to. It's just you would trust the hardware not to access those addresses, which you usually do anyway. Like if you don't have an SMU, you also trust that the hardware doesn't access stale functions.
I mean, addresses that the hardware accesses are heavily under control of user space, so no, I don't trust.
Oh, user space. Okay, yes, I was thinking of physical, like, okay.
Yeah, no,
That's
no.
different.
We rely heavily on the IMU to make things sane.
Right, because the IMU can be used in very different ways, and I was thinking of a completely different setup. Yes.
Right.
So if this is just for the GPU, and the GPU always points to user space, it's that's the same.
Yeah, I mean, there would be performance advantages to batching unmaps and consolidating to one TLB and validate. So doing that asynchronously would be, I think, something we want to do someday, but that's kind of a different topic, I suppose. Anyway, I mean, there's discussions on how to handle that. I'm less worried about that. I think some of the bigger questions are going to be when we start adding per process page tables for the GPU, so that your GLX gears process has a different GPU address space from your Windows server or something like that, a different address space on the GPU.
So they don't at the moment, but they could in the current.
They don't at the moment. Doing so involves things like the GPU changing the page table address in the menu. I don't know. That's
Yeah, we need separate page tables. So we need to be able to program separate page tables and then tell the GPU switch to this physical address, and then back and forth, back and forth.
So could this GPU share the page tables with the CPU, or is that not?
No, that's way beyond. I mean, that's kind of more of a server thing. This is more just trying to maintain a separate space for everybody.
Okay.
so. I mean, at any one point, it's not like. So I think the new direction is where the hardware block generates memory requests with some ACID or some hardware ID of the stream in the request, so that you can have a single set of page tables that handle multiple processes. For the current stuff, the GPU is really only running one thing at a time, so you don't have interleaving between memory accesses for GLX gears and your X server or something like that. So it's a little bit different from what they've been talking about so far as SVM, or SVM, I should say.
Is there more you want to talk about on the SMU topic, or are you good? No.
I don't know. I guess we should sit down with Lauren.
Yeah, we'll need to break out and explain
Okay.
how the driver's supposed to work, and then it's the API that's the problem. It's not so much the hardware; it's figuring out the right IOMU API.
Okay.
Right, the IMU API is certainly also different, has been for a number of years, because there's just no kernel API to do what everybody needs.
Yeah.
Does not sound very good.
Yep.
Great. So I mean, at least the SMU B family driver merged, right? So now we have SMU everywhere. Is that right?
Yeah.
On GPU land.
So the QCOM IMU, I said QCOM IMU for like the, I guess you call it early B family stuff, it is merged now. So we're using that on the 410, that we should in theory be able to use it for whatever, 8974 or
Yeah, I gave it a spin on 8974, and it doesn't seem like it. So several of the 64-bit registers seems to be 32-bit on 8974, and what goes in upper 32 bits currently is I think the AC ID, and writing that there is insta reboot. So I had to fiddle a little bit with the driver to get past a probe.
Yeah, we might need to add some like compatible string matching for different variants of that, like the 32-bit versus 64-bit platforms, would be my guess. But did you bring hardware with you?
No, but I can SSH to the normal.
Okay, well, we can sit down and play with that this week.
All right. I have Ion next, but I don't know what we can talk about Ion for specifically. Does anyone want to talk about Ion?
We have a separate BoF for
Okay, there's a separate buffer Ion. Good.
Do you guys want to summarize anything from LPC or anything that's still pending?
I didn't attend anything at Ion about LPC, but maybe Laura wants to talk about it.
Okay, so these past 2 weeks have been LPC and XDC, so there's been a bit of ION discussion. In general, I think the consensus from the community has been neutral to good. Nobody's been jumping up and down and saying don't do things, which I think is good progress. I think the biggest thing is the move towards splitting the ION ABI towards one dev ION, towards dev heap 0 to whatever, just for ease of locking things down. I've also had some offline discussions about other requirements. Mostly the biggest thing that's come up is that supporting various parts of the secure data path are tricky to get right in ION while still getting the right layer of abstraction. The biggest issue I'm thinking about right now is the fact that DMA buff is supposed to be for generic buffers, but ION has been used, especially in the Qualcomm tree, for a lot of specific secure, just a whole lot of secure buffer state. So trying to figure out the right level of abstraction there to do that, I think, is going to be the biggest issue there. I think as far as other generic ION upstreaming stuff, yeah, I think the split heaps are the biggest ones. Sumit, did you want to add anything else?
no, I think
Okay.
Okay. Beyond that, let's move on to a different topic completely, which would be power management. So I have my list here for power management, which apparently last time was everything was to do. And so it looks like there was RPM G-Link, which I think is now merged. That's all good to go. There was the suspend stuff, which never happened, like in Linaro. Andy was working on that, he kind of dropped off, stopped doing it. So there's a whole suspend path that's not being supported. Then there was this, looks like battery current limiting, nothing happened there. There was management, nothing happened there. CPU Freak, I think most of that got stuck. This was also for 8996 CPU Freak. I don't know what the status of that is. Is George working on that? Or was he? I don't know who's working on this. Gender?
so many constants. Yeah, any other.
Okay.
I don't think
Somebody
But that should pick back up again soon. I think the Qualcomm Israel team will see the driver.
So we should expect to see a highly complicated CPU Freak driver on it, unless it's actually for Qualcomm. I'm not sure when that will happen, but that's also on this to-do list. Then we have the clock and voltage scaling, DDFS. We've had Varesh working on that topic with Regency. I don't know if you want to talk about this at all.
you mean the corners.
Yeah, this would be corners as well.
So I think this is the performance state patches that Viresh has been working on. So I've been trying to use those and try to model a power domain driver for the corners. There are a couple of things. One, there are no DD bindings, so everything needs to be in the power domain drivers. So the power domain driver needs to now look up a table instead of it coming from device tree, as to which corner maps to what frequency and so on. So all that is part of the driver, which kind of makes it ugly. The other thing is we have cases where a device needs to work on multiple corners, which means we need to associate multiple power domains to a device, and there's no support for associating multiple power domains to a device. So I think those are in either open things.
Is that the solution there, though? I mean, it was rejected from the regulator framework as an API extension, right?
Yeah, I mean, I think we spoke with Mark for using the regulator framework, but then eventually it was without power domains would be the right place, but then we have this issue with you can't associate more than one power domain to a given device at this point.
Well, bigger than that.
So there is the problem if we can't associate more than one power domain to a device, but that seems like a solvable problem. The bigger problem is that in the case when we vote for what's the performance of that device, one of my build devices needs to vote for two different levels on the two power domains, and I don't want that to, or I can't have that tied to the PM runtime state of the device because it's only a transient thing. And if I have children who do the PM runtime votes, they should not affect.
I think that you should be able to ignore PM runtime ignore child. So there are ways to do that where that wouldn't affect your.
Yes, two things there. So first of all, runtime PM stuff is about idle management, so that's a big difference why we try to squeeze this in, of course. And we've been discussing this on the mailing list. On Plumos recently, we had a quick chat with Rafael and the PM Core guys about adding support for multiple power domains. And it got stuck sometimes during May discussion that we had. So we're trying to pick up that now again because there is interest from it's not just Qualcomm that needs it. It seems to be like NVIDIA folks are interested in this as well. So we should definitely pick that up.
Okay, so we want to continue with the power domain states, like the performance states, without considering this. Like you want to kind of like the current performance state APIs don't take into account like that there could be multiple power domains associated to a device. So when I spoke to Viresh, his answer was that support doesn't exist. So when it comes in, we'll probably think about it. I can't think of an API at this point. So that's how it's going to be. Like
I think so. We have to take small steps and fix one problem at a time.
Do you have an okay. Next I have bus and DDR scaling. That's been going on. George's been working on it. Do you want to talk about it?
Yeah, so there will be a separate discussion on this topic on Wednesday, so we can discuss this on more details. But there have been several RFCs and patches on the mailing list. There's some feedback, so we can discuss this on Wednesday, I think.
Okay. So just come to the, where's it at? What room? It's on the list.
Cypress C.
Okay.
That's 2 p.m.
So it's actually on Thursday at 2 p.m.
No, Wednesday, 2 p.m.
Wednesday at 2 p.m.
Yes.
Yeah.
Wednesday, no, yes, Wednesday.
Oh, Wednesday.
Wednesday 2 p.m. for sure.
Yes.
They're changing that, but it's not.
It
Wednesday
says
2
Thursday.
p.m.
The email says Thursday.
Yeah. Wednesday, 2 p.m.
Depends on whether they want you there or not.
Okay.
So,
Are you gonna announce this somewhere? And
Wednesday, normally it's on the schedule, normal schedule.
it's on the schedule.
Yeah.
Okay. So it will be found.
so a question on that front. I'm just going to give it back to him in a second. So how close is the RFC to the downstream driver, at least in terms of feature alignment?
So the question is how this compares with the downstream driver feature-wise.
Can it do everything that we need in the downstream driver?
Yes, currently we don't support all the types of constraints like latency and mostly the latency stuff, but all the bandwidth constraints are supported. And this is currently tested on the 410C, and there is also a driver with the topology for 820. Which is not complete yet, but...
Are the bindings squared away?
So currently we have dropped the bindings.
Oh yeah, okay, that's right.
And
yeah.
They're perfect.
So who else is in that discussion? What other companies are involved?
Not sure.
Because NVIDIA has asked about this a few times, so I'm sure they have their own driver that they want to get upstream eventually.
I don't know.
Really, invite them over.
Yeah, is NVIDIA here this week?
I haven't seen anybody now.
So,
But I meant on the mailing list.
It's on the mailing list. I've seen that some India guy made some comment in the schedule. That's it on the mailing list.
okay. After that topic, we have RPM clock control, which I think merged. That's all in place.
Is it?
Yeah, I merged it.
We're showing it with
Yeah, 4896. No.
It's just not that one. Is that right? But otherwise, everything else is there.
But if you say that you merged it, then you have until this evening to do so.
I have plenty of time. I can take care of it. And there's RPM regulators, which I think is also fine.
Yep.
That's all good. And then I have SPMI, PMIC arbiter. That's fully up to sync, I think, internally, actually, and externally. They're pretty much the same, which is pretty impressive. So that driver is like completely used inside the company now. And then after that, we have LPG, PWM. Do you want to talk about those?
So I've taken 2 stabs at the LED driver, and it's existing in all modern PMICs in various configurations, and the LED maintainers wants me to invent a couple of wheels on the way, because so one of the features is that you can provide patterns, so you can do smooth turn on and off of the or ramping of the brightness. So in the second iteration, I came up with a generic LED API for user space and user space interface for poking in a pattern or a ramp pattern that that drivers can implement, and yeah, that seemed quite reasonable. The other part of this puzzle is that there's a hardware block called TriLED, which has 3 pins called red, green, and blue, and you configure. So it's essentially just a 3-channel current sync, and you turn them on and off in the same register. So with one register right, you can toggle all 3 of them. Naturally, the LED maintainers want to expose this as a 3-channel RGB LED to user space. and there is no such thing beyond some vague ideas on the mailing list. So one could take that path and say that those three LED generators or PWMs should be handled separately or as a group, generating an RGB signal of some sort, and then the other 6 or whatever should expose some completely different interface. And then you look at what we have on the Dragon board, where those 3 lines goes to the colors green, green, and green. And they are 3 of the 4 green user LEDs. And according to 96 board specification, we're supposed to have different, or be able to have different triggers, for example, on those. So in this particular board, it's not red, green, and blue line. It's just 3 current sinks. And the 4th user LED comes from a separate current sink that then is, and they all 4 looks exactly the same user space in my current proposal. But I'm requested to expose them as an RGB LED if there is an RGB LED hooked up to those lines, and I have no idea how to do the DT binding for that, or how to make the code so that so I can, in some cases, interface it from user space as a 3-channel thing, in some cases has 3 different LEDs, and how to do the synchronization of those things.
It reminds me of something that came up earlier, which was the 7-segment LEDs, which had the same problem. You might have a 7-bit output that's 7 separate LEDs, or you could have them as a digit that you display.
Yes, when you have 3, or when you have when you have a bunch of LEDs that might be configured in that setup. Yeah, that would be exactly the same case, that depending on which board or what you actually hook those lines up to, you want a different interface to user space. And I was hoping to be able to ignore the RGB part for now, because it would both be sufficient for the driver board, and it would be on par with what everyone at Qualcomm expects. And then as a second step, someone else could try to figure out how to do the RGB thing. But I think that all the review comments I got on that second revision was about the lack of this thing. Well, that and the DT binding. So I described each hardware block as one piece in the DT binding, and the LED guy said, would it be better to have these as one chunk? But there are cases where all we have is one of these PWM blocks and nothing more. And there are cases where we have 8 of the PWM blocks. There is a pattern block and the current sync block. So that DT binding, to be able to describe those, the variations in between there is turning out to be quite not so clean.
Is it not just changing the compatible in a different board file? Is it much more complicated? Well, it's just compatible string. It's not exactly.
Yeah, so we could encode some of this in the compatible, but when I'm punching that out, it's not. It doesn't look good, and then as a side effect of that, I have to say that the 960 version of this, where there is just a PWM part, I would say that that's a PWM block. So maybe that driver should just go into PWM subsystem, and then the other part should go into LED subsystem. But suddenly we have a lot of duplicate code, because all the math and everything that goes into figuring out what numbers put in registers has to go in both. So, yeah.
There's no good answer.
I haven't found a good answer, and but it's back on my table. I started looking at it last week again.
Okay. So we'll see what happens. All right. After this, we have clock and power main handoff. If Rob wants to talk about this.
All right. So one of the things we have to tackle eventually for display in particular, and I don't really know if there's any other cases where this matters, but display in particular, we need to be able to hand over clocks and power domains from the bootloader, so that you can have the bootloader light up the splash screen and the kernel not freak out when it discovers that hey, some clocks are on already. So I kind of hacked up something a month or two back on the 410C. I think there was a different effort by someone with constraints or something. Yeah. So in particular, I definitely need to look at the hardware state to see if things are enabled or not. Because you could have the case where you power on the device without a monitor plugged in and it doesn't light up the display. So what I hacked up was in GPC and the GTSC driver. In the clock driver, there was just a flag you put on leaf node clocks that say, hey, check if this is on when the driver probes. And if it is, it propagates the data state up the tree to get the ref counting for all the clocks right. And you have to enable counting.
And who would lower the ref count again?
So there's two halves of this. So there's three halves of this. That's the clock driver half. The GDSC does a similar thing. And then I just export symbol the already existing underscore clock is enabled. So I could call that from my driver. On the display driver side, it starts from the root of each display chain. So if you think of the display chain as overlays to mixers to encoder to HDMI or to DSI or whatever. So each of the output blocks checks and sees whether it's VSync or pixel clock is enabled. And if it is, it works up the chain leading back the state from the hardware and basically skips it corresponding enable. So it says, okay, I'm already enabled. I don't need to enable this clock.
I don't understand. So what would it hurt to enable it again if it's already in?
Well, then if you enable it again, then your enable count is one too high, and when you want to disable it to change resolution, for example, it doesn't work.
No, but why do you have to add to the count initially? So you don't turn it off? Or?
Yeah, so there's two cases. One is where the display driver loads before user space and before the clock driver disables unused clocks. And the other case is where it loads after. So if you load after unused clocks, you want BFI FB to keep working. So like when you get to user space, but before your display driver as a kernel module is loaded, you don't want to cut the clock so BFI will be used.
Okay.
Or simple FB.
Yes.
But EFI FB is a tricky case because there's no DT binding for it that we could hide some clock references in.
Now this is similar to the things we've had in other drivers before. Let's maybe talk about that later. Okay. I think there's a solution for this. I just need to remember what it exactly is.
Yeah. I mean, on the display driver side, there's some fairly different paths if things are already enabled. So from my point of view, not doing an extra clock enabled because we discovered it's already enabled.
So the typical case was for the serial port where you definitely don't want to disable the clocks for the console, even if you haven't loaded the serial port driver. You should still use the boot console.
Okay.
And I think I guess should do whatever that does.
That's a similar case, but it's not quite as catastrophic as a display.
In that case, a couple of SoC vendors have merged code into their clock driver that just turns things on one time. It's actually quite ugly, and I would prefer we don't do it that way.
That was the solution I'm thinking of.
Okay, is there something else? Because I know this is doing that for the debug, like the early console stuff, like the before your console exists, they need to keep their clocks on and keep the boot console existing forever without the driver probing, and they just have some clock code for at least like 1891, I think, or something like those. I merged all this code. So,
yeah. Well, I mean, serial is a very simple case because
Right, but it sounds like this is basically the same problem. It's just you have it in more places at once.
Yeah. So I mean, as far as the driver needing to know about this, the driver's going to need to know that it was enabled at boot up anyways, because it needs to read back the state. It wants to go figure out, oh, you're running at 1080p at 4 bytes per pixel color format, and it's actually going to go try and find the scan out buffer, so it can reuse that as things hand over to the kernel.
So the traditional way to do that would be to have the bootloader put the state in the device tree.
Yeah, so what I have LK adds is a simple frame buffer node in device tree. Usually that's used by U-boot, so I added a simple FB driver in U-boot, which can use the simple FB bindings from LK to give you EFI cop. So you have EFI when you boot the kernel.
Right, but that wouldn't have the properties that you want, right? It wouldn't have a link to the clocks that are already enabled into the exact frame buffer format.
We get the, I guess in theory we could get the frame buffer format from COP. We get the address from COP. When we kick out the frame buffer FBs, we go find their aperture, so that's how we know where the actual frame buffer is. And the frame buffer format we figure out just by reading registers in the hardware pipe, the front end of the display pipeline. And that's like one of the easier things the display driver has to do to re-sync its state with the hardware. The harder thing is figuring out the mapping between hardware pipes and mixers and interfaces and SMP block assignment.
And you don't want that all in the bindings, because that would add lots of properties.
Yeah, no, it's way too much to put in bindings. You just have to read the hardware state back.
But for the clock reference, that sounds like something that could be in there, because it's not just this one device that you're talking about. It's actually something where you're talking to another device.
Yeah, I mean, from a Linux device standpoint, there'll be like an HDMI or a DSI device plus the display controller device. Each of those is going to reference a handful of clocks. There'll be some clocks provided by DSI or HDMI, which are parents of stuff that come from GCC or MMCC. It's kind of a complicated clock tree. Yeah, but.
So does Russia stuff you looked at?
Not too. I looked at it briefly, but it looked like it was kind of static. I might have been misunderstanding. I mean, I definitely want to be able to look at the state of the clock at boot and tell, oh, this is actually enabled by the bootloader or not. Because like I said, the bootloader may or may not enable display depending on whether it's plugged in or not. So it has to be, it can't be something static. I mean, I guess the bootloader can stick something in chosen or something. But sure.
And you don't need anything from RPM.
RPM is a parent of some of this. I think we get, like RPM has parent clocks of parent. So it's somewhere up in the clock chain, and I think we just end up getting lucky that it's probed before, because the whole like reparenting things when clock drivers load out of order makes it kind of.
Yeah, because you have both those clocks and regulators, so we don't have a way to read the state.
Yeah, I mean the thing is you only need to know the leaf node. If you know the leaf node, you know that the whole.
Yeah, but the regulators might fall in that category if you ever had one. But
yeah.
As long as you don't.
The current hardware I've looked at, it's all GDSCs, so there's a bit we can look at.
But what about panels?
Pardon?
The only case would be like something shared, the panel and stuff.
It'd be something like a shared case between a panel and something on the SoC. I don't know if that ever happens. I can't remember.
Well, it won't matter if you just write another enable.
If you call enable, I mean?
Yeah, I mean, if you just turn it on, because you can tell something else is turned on.
Yeah, as long as you make that call before you turn the clock off, or you turn the regulator off for us.
Yeah, but the whole thing with Varesh's thing is supposed to be that you don't turn things off. I mean, I thought the discussion was purely about the initialization state. I mean, you don't. I don't see what relevance the turning it off has to the question.
So I think the biggest problem is that well, the case I'm thinking of is one driver probes early before display, it gets the regulator and then it turns it off.
Yeah, but the whole point with Varesh's stuff was to make the turn-offs not happen.
Okay.
It's a handover. Sorry. So you just don't turn it off before the point where you turn them all off?
No, it's not. You need to stop turning stuff off because you can't. You need to. You might have the display in a loadable module or something, which could get loaded at any time by user space. But really, all this stuff is custom hacks for specific devices anyway. So it's kind of irrelevant to handle it properly, and the hacks actually work fine. But yeah, you can't tell when things are going to get turned off. When you do want to turn things off clearly, but there's never a moment when it's possible to do that unless you sync with user space. And there's some resistance to syncing with user space for reasons that are not super clear to me. So I'm not sure what Varesh's stuff actually does, because
what Varesh is working on is mainly trying to take some resource.
Yeah, I know theory. I know the high level. I just don't know the concretely what his proposal is right now.
In the implementation.
Yeah.
So the goal is that in the early beginning you will take some resources. Yeah, at the early beginning you will take some resources until the device gets probed, and once it's probed, it will release this early constraint. So the goal is just to make sure that we'll, for example, the case of the regulator for the display will just take the voltage, set the voltage constraint until the LCD driver will apply its own constraint. And the goal is, so at the end, I think the goal would be to set that with the mining or whatever can be used.
Okay, that might end up being part of the equation then for like LCD panels on a board. I mean,
Well, that's the entire purpose of it.
Yeah, I mean that's a case I mean so far I've been thinking more about built-in HDMI or the built-in bridge chip, DSI HDMI bridge. For panels which have their own regulator, we might want that in addition to what I'm thinking.
It's not. It's also it handles clocks as well, because that's one of my big. He's trying to do some. He was trying to push the same appalling crap everybody else has been trying to push for. It was regulator specific, but obviously you need clocks for all this stuff as well. So the big thing with what he's doing is it should handle at least regulators and clocks, and probably any other resources. Like you don't want pin control to put the pins into sleep state either, for example.
Yeah.
Yeah.
I mean, I guess if it could take a reference without, for example, a clock, if it could take a reference to the clock without enabling the clock, and then let the driver, when it loads, check the clock state to decide what to do, maybe that could work. I don't know.
Okay, right out of time. Can we stop talking about this topic? Move on to something else. Okay. So next I have is peripheral stuff like UFS, USB, PCIe. I think all of this is fine.
PCIe needs the aggro thing.
Okay, so PCIe is the only thing that's blocked on no bus driver or turning on some power that's not exactly the same as whatever PCIe is connected to.
We can turn on the GDSC, but we don't have a way to turn on the clocks.
For the aggro dock?
Yes.
Okay. Is that all that is?
Yeah.
Okay.
There's a MSI auto patch for there's a patch missing for Gig to support the MSI.
Oh yeah, that was blocked on Mark telling me that we need to support it for not just level, I think.
And it's V2 patch something like that.
Yeah, so there's the whole, I wrote this patch, right, we sent it out, and they got stalled, completely stalled, because Mark asked something about what if an MSI is not just level triggered, I think.
MSI is not level triggered.
Or it's not just edge triggered. And he's saying maybe they could also be level triggered. I think he was saying something else, and I didn't understand what he said, and I just ignored him, and I just forgot about it. It was great, because I need to talk to Mark if he's here. I don't know if he's here.
Yeah.
No, okay. I'll talk to him over email. We can resolve this.
Okay.
Basically, you just want to re-kickstart that topic. Is that what you're saying? Okay.
But what did we conclude about the SFU there?
The aggregate knock?
Yeah.
I thought are you going to do something?
We came to an agreement, but I forgot what it was.
The agreement was he would do everything.
Well, I hope you do it. But,
yeah, I think that was part of the agreement, but I forgot what I was supposed to do.
I think you were gonna try pushing that simple PM bus, but not simple PM bus. Another
simple PM clock bus.
Simple PM clock bus. You're gonna push that one.
The Arn would say no.
Well,
Tell you what it is.
So we have the simple bus that just groups devices. We have the simple PM bus that that associate the power domain with a bus. The problem is that we have a couple of clocks that also needs to be enabled at this point, and they are well. The way it works right now is that, and the way it looks is that the power domain should have those clocks associated. So when we just enable the power domain, those clocks should be enabled. Except for Steven's comment that those clocks are not related to the power domain. It just happens to be that they are there, because what we actually have is an SMU that's in full bypass mode and pre-configured. So I mean, either we would describe that simple PM bus clock thing to do clock enablement and bus enablement, or we would make up a dummy SMU device to represent what's actually there in hardware, but Linux would never see.
So could you have another power domain that just inherits from the real power domain and from the two clocks? And so you have a very simple power domain driver and the regular power domain.
So the problem isn't that. The problem is that the power domain, or the maintainer who would take who is responsible for the driver for this power domain, says these clocks does not relate to this power domain. Therefore, I don't want to add these clocks to the list of clocks for this power domain, because the clocks are completely unrelated to the power domain.
Those are bus clocks, actually.
So there is there's a power domain and there is an SMU, and the clocks for the SMU are not directly related to the power domain. So what we normally would do is we would do an IMMU attach or whatever, and that would turn on those clocks. Except we don't have an IMMU because Linux doesn't see that IMMU. So either we make up a...
So it could be a trivial IMMU that doesn't any translations. That
I don't know if
IMMU framework
or null IMMU driver.
Yeah, I mean there is actually an IMMU driver there which you can describe in the DT.
Well, the device that's better.
Yeah, exactly. So you could in device tree describe exactly what the hardware is.
Yeah, which is.
But then we need to upstream an IMMU driver that doesn't do anything.
I don't think that the IMMU layer can do that. Like the IMMU subsystem could handle. It couldn't handle IMMUs that don't do any dynamic translation. I'm not completely sure about that.
They could have arranged to support the binding though, and or you wouldn't necessarily need to go into the actual IMMU subsystem because it isn't doing anything.
Well, we make certain assumptions. Like if you have an IMMU, we make the assumption that you can address all of the address space.
Yeah, but they don't. They can just go, oh, this is a trivial IMMU. I'm not going to actually register as a proper IMMU because this is.
So the driver would fail to register but enable the clocks?
Well, or it would...
But we only want the clocks enabled when one of the children actually is there and is going to be on.
Okay, now it's solved.
What was the big thing?
There's an IMMU domain identity, so I mean, presumably the there's some way to create an IMMU that only supports the identity domain. Yeah. This is something I stumbled across the other day. It seemed like it.
How convenient.
Does anybody use it? Does it work?
Hopefully not.
Okay. Well, it sounds like we need to make a whole IMMU driver though. That does nothing.
And hope that it's just a few lines.
And
That does power management.
probably make the simple PM bus use that, or should we make the
bus card?
No, the simple PM bus would just
or is the
go
IMMU
away.
of the PCI devices? Yeah, but you
Yeah.
and then
Your PCI device would have some IMMU that does nothing besides go to
Well, if you have a
bypass it.
If you have a PCI bus, you certainly do want a full IMMU. Because you have a lot of PCI devices that that are limited to 32-bit DMA, but they do want to address high memory. So if there's a hardware IMMU, the only thing that's on it is the PCI bus, you really, really want a proper IMMU driver for it.
But the firmware we have will never use it though, and will never be unlocked.
What does the firmware care about it?
The firmware is sandboxing basically the PCI memory space from the rest of the system to the IMMU, and not letting the PCI device and Linux control that sandboxing.
And the problem with removing the simple PM bus, I think that all the PCI devices already have a power domain, or they have their individual power domains. So we still need to represent the channel out that GDSC as a parent power domain. Or we need to.
Or you make an IMMU, and then the IMMU is turned on when it's attached. That does nothing. I mean, it's just a completely semantical thing at this point.
Well, I'm a little bit scared. So.
As am I. Let's just push both. At the
Needs
clock
PCIe anyways.
Yeah.
So usually the situation is within IMMU where the OS is not in full control of the hardware, that the IMMU is programmed through a firmware interface of some sort. But of course, your firmware probably doesn't have an interface for that. You do? Yeah, well, we could use it. We could have an IMMU driver that just talks to the firmware.
No. We're not going to expose that.
But then how do you use old PCI devices or cheap PCI devices? So do you only support Qualcomm PCI devices that have been qualified for this?
Vendor lock-in.
IBM does this. Like they have a mainframe with a complete PCI implementation that only supports 3 devices.
But all those Wi-Fi things as well.
Yeah.
I don't know what's going on. Yeah, we're out of time now. We're 1 minute past, but so we have to end now. But I think this PCA thing, I mean, no one's going to do anything, at least with this existing hardware we have. Right? We're not going to change from it.
Does anybody use PCI?
I don't know how it's going to work. So we need to look at it.
We only use this for Ethernet and Wi-Fi on the Dragon board.
So
there's a slot though.
So maybe not expose PCI at all, just set it up in firmware and make it platform devices.
I only use it for SATA.
Yeah, so then all we're down to is how do we control these clocks?
Well, then you have platform devices and clocks. That's easy.
Yeah, but then we have a custom. So we have a custom driver that's parenting the other ones, so that we get the pure runtime parts in place. And then we have sort of 2 dummy parents just to deal with that. And add that next to the other 5-line driver, which simple PM bus is, which is 1 line more than the simple bus driver.
What we should do is make it a PT node that says null SMB or something, and then attach the PM clock driver.
The no IOMMU driver.
Yeah, but no
Slightly less simple.
All right. Yeah.
I think we're done, unless you want to stick around and talk more, but that's it. I had a lot of other topics, but we didn't gotta get to them.
What are your other topics?
Display, GPU, video,
Oh, we saw
network. I would talk about some of those. So. If you want to stay, I think there's nothing else going on after this session anyway.
It's the employee meeting.
Yeah, have fun at the employee meeting.